Welcome back. It's Friday. It's soon 3 p.m. Let's read about F-16. So I did pay my bills yesterday, Thursday. It's Friday today. It's Friday 2nd. But this is not an English vlog video. I like to read about the fighter jets. Denmark, the Danish Air Force have this F-15, F-16, but they have the F-35. They changed the F-16 to the F-35. And many the Danish F-16 they are donated to Ukraine. So they're flying around in Ukraine now.
General Dynamics F-16 Fighting Falcon. F-16 and F-16 Fighting Falcon redirect here. For the video game, see Falcon, video game series. For other uses, see F-16, disambiguation. The General Dynamics F-16 Fighting Falcon is an American single-engine supersonic multi-role fighter aircraft originally developed by General Dynamics for the United States Air Force, USAF. Designed as an air superiority day fighter, it evolved into a successful all-weather multi-role aircraft with over 4,600 builds since 1976. Although no longer purchased by the U.S. Air Force, improved versions are being built for export. In 1993, General Dynamics sold its aircraft manufacturing business to the Lockheed Corporation, which became part of Lockheed Martin after a 1995 merger with Martin Marietta. The F-16's key features include a frameless bubble canopy for enhanced cockpit visibility, a side-mounted control stick to ease control while maneuvering, an ejection seat reclined 30 degrees from vertical to reduce the effect of G-forces on the pilot, and the first use of a relaxed static stability forward/fly-by-wire flight control system that helps to make it an agile aircraft. The fighter has a single turbofan engine, an internal M61 Vulcan cannon and 11 hardpoints. Although officially named Fighting Falcon, the aircraft is commonly known by the nickname Viper among its crews and pilots. In addition to active duty in the U.S. Air Force Reserve Command, and Air National Guard units, the aircraft is also used by the U.S. Air Force Thunderbirds Aerial Demonstration Team, the U.S. Air Combat Command F-16 Viper Demonstration Team, and as an adversary forward/aggressor aircraft by the United States Navy. The F-16 has also been procured by the air forces of 25 other nations. As of 2025, it is the world's most common fixed-wing aircraft in military service, with 2,084 F-16s operational. Development, edit. Lightweight Fighter Program, edit. Main article, Lightweight Fighter Program. US-Vietnam War experience showed the need for air superiority fighters and better air-to-air training for fighter pilots. Based on his experience in the Korean War and as a fighter tactics instructor in the early 1960s, Colonel John Boyd with mathematician Thomas Christie developed the energy maneuverability theory to model a fighter aircraft's performance in combat. Boyd's work called for a small, lightweight aircraft that could maneuver with the minimum possible energy loss and which also incorporated an increased thrust-to-weight ratio. In the late 1960s, Boyd gathered a group of like-minded innovators who became known as the Fighter Mafia, and in 1969, they secured Department of Defense funding for General Dynamics and Northrop to study design concepts based on the theory. Air Force FX proponents were opposed to the concept because they perceived it as a threat to the F-15 program, but the USAF's leadership understood that its budget would not allow it to purchase enough F-15 aircraft to satisfy all of its missions. The Advanced Day Fighter concept, renamed FXX, gained civilian political support under the reform-minded Deputy Secretary of Defense David Packard, who favored the idea of competitive prototyping. As a result, in May 1971, the Air Force Prototype Study Group was established, with Boyd a key member, and 2 of its 6 proposals would be funded, one being the Lightweight Fighter, LWF. The request for proposals issued on the 6th of January 1972 called for a 20,000 pound, 9,100 kilograms, class air-to-air day fighter with a good turn rate, acceleration, and range, and optimized for combat at speeds of Mach 0.61.6 and altitudes of 30,000 40,000 feet, 9,112,000 m. This was the region where USAF studies predicted most future air combat would occur. The anticipated average flyaway cost of a production version was $3 million. This production plan was hypothetical as the USAF had no firm plans to procure the winner. Selection of finalists and flyoff, edit. 5 companies responded, and in 1972, the Air Staff selected General Dynamics Model 401 and Northrop's P600 for the follow-on prototype development and testing phase. GD and Northrop were awarded contracts worth $37.9 million and $39.8 million to produce the YF-16 and YF-17, respectively, with the first flights of both prototypes planned for early 1974. To overcome resistance in the Air Force hierarchy, the fighter mafia and other LWF proponents successfully advocated the idea of complementary fighters in a high-cost forward/low-cost force mix. The high forward/low mix would allow the USAF to be able to afford sufficient fighters for its overall fighter force structure requirements. The mix gained broad acceptance by the time of the prototype's flyoff, defining the relationship between the LWF and the F-15. The YF-16 was developed by a team of General Dynamics engineers led by Robert H. Widmer. The first YF-16 was rolled out on the 13th of December, 1973. Its 90-minute maiden flight was made at the Air Force Flight Test Center at Edwards AFB, California, on the 2nd of February, 1974. Its actual first flight occurred accidentally during a high-speed taxi test on the 20th of January, 1974. While gathering speed, a roll control oscillation caused a fin of the port side wingtip-mounted missile and then the starboard stabilator to scrape the ground, and the aircraft then began to veer off the runway. The test pilot, Phil Eastricher, decided to lift off to avoid a potential crash, safely landing 6 minutes later. The slight damage was quickly repaired and the official first flight occurred on time. The YF-16's first supersonic flight was accomplished on the 5th of February, 1974, and the second YF-16 prototype first flew on the 9th of May, 1974. This was followed by the first flights of Northrop's YF-17 prototypes on the 9th of June and the 21st of August, 1974, respectively. During the flyoff, the YF-16's completed 330 sorties for a total of 417 flight hours. The YF-17's flew 288 sorties, covering 345 hours. Air Combat Fighter Competition, edit. Increased interest turned the LWF into a serious acquisition program. NATO allies Belgium, Denmark, the Netherlands, and Norway were seeking to replace their F-104G Starfighter fighter bombers. In early 1974, they reached an agreement with the US that if the USAF ordered the LWF winner, they would consider ordering it as well. The USAF also needed to replace its F-105 Thunderchief and F-4 Phantom II fighter bombers. The US Congress sought greater commonality in fighter procurements by the Air Force and Navy, and in August 1974 redirected Navy funds to a new Navy Air Combat Fighter program that would be a naval fighter bomber variant of the LWF. The four NATO allies had formed the Multinational Fighter Program Group, MFPG, and pressed for a US decision by December 1974. Thus, the USAF accelerated testing. To reflect this serious intent to procure a new fighter bomber, the LWF program was rolled into a new Air Combat Fighter, ACF, competition in an announcement by U.S. Secretary of Defense James R. Schlesinger in April 1974. The ACF would not be a pure fighter, but multi-role, and Schlesinger made it clear that any ACF order would be in addition to the F-15, which extinguished opposition to the LWF. ACF also raised the stakes for GD and Northrop because it brought in competitors intent on securing what was touted at the time as the arms deal of the century. These were Dassault Breguet's proposed Mirage F-1M53, the Anglo-French Sea-Picat Jaguar, and the proposed Saab 37E Eurofighter. Northrop offered the P530 Cobra, which was similar to the YF-17. The Jaguar and Cobra were dropped by the MFPG early on, leaving 2 European and 2 US candidates. On the 11th of September 1974, the US Air Force confirmed plans to order the winning ACF design to equip 5 tactical fighter wings. Though computer modeling predicted a close contest, the YF-16 proved significantly quicker going from one maneuver to the next and was the unanimous choice of those pilots that flew both aircraft. On the 13th of January 1975, Secretary of the Air Force John L. McLucas announced the YF-16 as the winner of the ACF competition. The chief reasons given by the Secretary were the YF-16's lower operating costs, greater range, and maneuver performance that was significantly better than that of the YF-17, especially at supersonic speeds. Another advantage of the YF-16 unlike the YF-17 was its use of the Pratt & Whitney F-100 turbofan engine, the same power plant used by the F-15. Such commonality would lower the cost of engines for both programs. Secretary McLucas announced that the USAF planned to order at least 650, possibly up to 1,400 production F-16s. In the Navy Air Combat Fighter competition, on the 2nd of May 1975, the Navy selected the YF-17 as the basis for what would become the McDonnell Douglas F/A-18 Hornet. Production, edit. An F-16C of the Colorado Air National Guard with AIM-9 Sidewinder missiles, an air combat maneuvering instrumentation pod, and a centerline fuel tank, 300 US gal or 1,100 L capacity. The US Air Force initially ordered 15 full-scale development, FSD, aircraft, 11 single-seat and 4 two-seat models, for its flight test program which was reduced to 8, 6 F-16A single-seaters and 2 F-16B two-seaters. The YF-16 design was altered for the production F-16. The fuselage was lengthened by 10.6 in, 0.269 m. A larger nose radome was fitted for the IN/APG-66 radar. Wing area was increased from 280 to 300 square feet, 26 to 28 m. The tail fin height was decreased, The ventral fins were enlarged, 2 more stores stations were added, and a single door replaced the original nose wheel double doors. The F-16's weight was increased by 25% over the YF-16 by these modifications. The FSD F-16s were manufactured by General Dynamics in Fort Worth, Texas, at United States Air Force Plant 4 in late 1975. The first F-16 rolled out on the 20th of October, 1976 and first flew on the 8th of December. The initial 2-seat model achieved its first flight on the 8th of August, 1977. The initial production standard F-16 flew for the first time on the 7th of August, 1978 and its delivery was accepted by the USAF on the 6th of January, 1979. The aircraft entered USAF operational service with the 34th Tactical Fighter Squadron, 388th Tactical Fighter Wing, at Hill AFB in Utah, on the 1st of October, 1980. The F-16 was given its name of Fighting Falcon on the 21st of July, 1980. Its pilots and crews often use the name Viper instead, because of a perceived resemblance to a viper snake as well as to the fictional colonial Viper starfighter from the television program Battlestar Galactica, which aired at the time the F-16 entered service. On the 7th of June, 1975, the 4 European partners, now known as the European Participation Group, signed up for 348 aircraft at the Paris Air Show. This was split among the European Participation Air Forces, EPAF, as 116 for Belgium, 58 for Denmark, 102 for the Netherlands, and 72 for Norway. 2 European production lines, one in the Netherlands at Fokker's Schifoluust facility and the other at Subke's Gosselais plant in Belgium, would produce 184 and 164 units respectively. Norway's Kongsberg Våpenfabrik and Denmark's Terma/S also manufactured parts and sub-assemblies for EPAF aircraft. European co-production was officially launched on the 1st of July, 1977 at the Fokker factory. Beginning in November, 1977, Fokker-produced components were sent to Fort Worth for fuselage assembly, then shipped back to Europe for final assembly of EPAF aircraft at the Belgian plant on the 15th of February, 1978. Deliveries to the Belgian Air Force began in January, 1979. The first Royal Netherlands Air Force aircraft was delivered in June, 1979. In 1980, the first aircraft were delivered to the Royal Norwegian Air Force by Fokker and to the Royal Danish Air Force by Subke. During the late 1980s and 1990s, Turkish Aerospace Industries, TAI, produced 232 Block 30/40/50 F-16s on a production line in Ankara under license for the Turkish Air Force. TAI also produced 46 Block 40s for Egypt in the mid-1990s and 30 Block 50s from 2010 onwards. Korean Aerospace Industries opened a production line for the KF-16 program, producing 140 Block 52s from the mid-1990s to mid-2000s decade. If India had selected the F-16 for its medium multi-role combat aircraft procurement, a 6th F-16 production line would have been built in India. In May 2013, Lockheed Martin stated there were currently enough orders to keep producing the F-16 until 2017. Improvements and upgrades, edit. One change made during production was augmented pitch control to avoid deep stall conditions at high angles of attack. The stall issue had been raised during development but had originally been discounted. Model tests of the YF-16 conducted by the Langley Research Center revealed a potential problem, but no other laboratory was able to duplicate it. Why F-16 flight tests were not sufficient to expose the issue. Later flight testing on the FSD aircraft demonstrated a real concern. In response, the area of each horizontal stabilizer was increased by 25% on the Block 15 aircraft in 1981 and later retrofitted to earlier aircraft. In addition, a manual override switch to disable the horizontal stabilizer flight limiter was prominently placed on the control console, allowing the pilot to regain control of the horizontal stabilizers, which the flight limiters otherwise lock in place, and recover. Besides reducing the risk of deep stalls, the larger horizontal tail also improved stability and permitted faster takeoff rotation. In the 1980s, the Multinational Staged Improvement Program, MSIP, was conducted to evolve the F-16's capabilities, mitigate risks during technology development, and ensure the aircraft's worth. The program upgraded the F-16 in 3 stages. The MSIP process permitted the quick introduction of new capabilities, at lower costs and with reduced risks compared to traditional independent upgrade programs. In 2012, the USAF had allocated $2.8 billion, $3.67 billion in 2023, to upgrade 350 F-16s while waiting for the F-35 to enter service. One key upgrade has been an AUTOCAS, ground collision avoidance system, to reduce instances of controlled flight into terrain. Onboard power and cooling capacities limit the scope of upgrades, which often involve the addition of more power-hungry avionics. Lockheed won many contracts to upgrade foreign operators' F-16s. BAE Systems also offers various F-16 upgrades, receiving orders from South Korea, Oman, Turkey, and the US Air National Guard. BAE lost the South Korean contract because of a price breach in November 2014. In 2012, the USAF assigned the total upgrade contract to Lockheed Martin. Upgrades include Raytheon's Center Display Unit, which replaces several analog flight instruments with a single digital display. In 2013, sequestration budget cuts cast doubt on the USAF's ability to complete the Combat Avionics Programmed Extension Suite, CAPES, a part of secondary programs such as Taiwan's F-16 upgrade. Air Combat Command's General Mike Hostage stated that if he only had money for a Service Life Extension Program, SLIP, or CAPES, he would fund SLIP to keep the aircraft flying. Lockheed Martin responded to talk of CAPES cancellation with a fixed-price upgrade package for foreign users. CAPES was not included in the Pentagon's 2015 budget request. The USAF said that the upgrade package will still be offered to Taiwan's Republic of China Air Force, and Lockheed said that some common elements with the F-35 will keep the radar's unit costs down. In 2014, the USAF issued a RFI to SLIP 300 F-16C/DS. Production relocation, edit. To make more room for assembly of its newer F-35 Lightning II fighter aircraft, Lockheed Martin moved the F-16 production from Fort Worth, Texas to its plant in Greenville, South Carolina. Lockheed delivered the last F-16 from Fort Worth to the Iraqi Air Force on the 14th of November, 2017, ending 40 years of F-16 production there. The company resumed production in 2019, though engineering and modernization work will remain in Fort Worth. A gap in orders made it possible to stop production during the move. After completing orders for the last Iraqi purchase, the company was negotiating an F-16 sale to Bahrain that would be produced in Greenville. This contract was signed in June 2018, and the first planes rolled off the Greenville line in 2023. Design, edit. Overview, Edit. The F-16 is a single-engine, highly maneuverable, supersonic, multi-role tactical fighter aircraft. It is much smaller and lighter than its predecessors but uses advanced aerodynamics and avionics, including the first use of the Relaxed Static Stability Forward/Fly-by-Wire, RSS /FBW, flight control system, to achieve enhanced maneuver performance. Highly agile, the F-16 was the first fighter aircraft purpose-built to pull 9G maneuvers and can reach a maximum speed of over Mach 2. Innovations include a frameless bubble canopy for better visibility, a side-mounted control stick, and a reclined seat to reduce G-force effects on the pilot. It is armed with an internal 20mm M61 Vulcan cannon in the left wing root and has multiple locations for mounting various missiles, bombs and pods. It has a thrust-to-weight ratio greater than 1, providing power to climb and vertical acceleration. The F-16 was designed to be relatively inexpensive to build and simpler to maintain than earlier generation fighters. The airframe is built with about 80% aviation-grade aluminum alloys, 8% steel, 3% composites, and 1.5% titanium. The leading-edge flaps, stabilators, and ventral fins make use of bonded aluminum honeycomb structures and graphite epoxy lamination coatings. The number of lubrication points, fuel line connections, and replaceable modules is significantly less than in preceding fighters. 80% of the access panels can be accessed without stands. The air intake was placed so it was rearward of the nose but forward enough to minimize airflow losses and reduce aerodynamic drag. Although the LWF program called for a structural life of 4,000 flight hours, capable of achieving 7.33 G with 80% internal fuel, GD's engineers decided to design the F-16's airframe life for 8,000 hours and for 9G maneuvers on full internal fuel. This proved advantageous when the aircraft's mission changed from solely air-to-air combat to multi-role operations. Changes in operational use and additional systems have increased weight, necessitating multiple structural strengthening programs. General Configuration, Edit. F-16CJ of the 20th Fighter Wing from Shaw AFB, South Carolina, armed with a mix of air-to-air missiles, anti-radiation missiles, external fuel tanks and support equipment. The F-16 has a cropped delta wing incorporating wing fuselage blending and four-body vortex control strakes, a fixed geometry, underslung air intake, with splitter plate, to the single turbofan jet engine, a conventional triplane empennage arrangement with all moving horizontal stabilator tailplanes, a pair of ventral fins beneath the fuselage aft of the wing's trailing edge, and a tricycle landing gear configuration with the aft retracting, steerable nose gear deploying a short distance behind the inlet lip. There is a boom-style aerial refueling receptacle located behind the single-piece bubble canopy of the cockpit. Split-flap speed brakes are located at the aft end of the wing body fairing, and a tail hook is mounted underneath the fuselage. A fairing beneath the rudder often houses ECM equipment or a drag chute. Later F-16 models feature a long dorsal fairing along the fuselage spine, housing additional equipment or fuel. Aerodynamic studies in the 1960s demonstrated that the vortex lift phenomenon could be harnessed by highly swept wing configurations to reach higher angles of attack, using leading-edge vortex flow off a slender lifting surface. As the F-16 was being optimized for high combat agility, GD's designers chose a slender cropped delta wing with a leading edge sweep of 40 degrees and a straight trailing edge. To improve maneuverability, a variable camber wing with a NACA 64204 airfoil was selected. The camber is adjusted by leading edge and trailing edge flaperons linked to a digital flight control system regulating the flight envelope. The F-16 has a moderate wing loading, reduced by fuselage lift. The vortex lift effect is increased by leading edge extensions, known as strakes. Strakes act as additional short span, triangular wings running from the wing root, the junction with the fuselage, to a point further forward on the fuselage. Blended into the fuselage and along the wing root, the strake generates a high-speed vortex that remains attached to the top of the wing as the angle of attack increases.